Irrational numbers. Say we are given a right angle triangle. That means this angle is 90 degrees. Let's name our right triangle. Let's call it A, B, C. Also, let's say it is given that the length AB is 1 unit, length BC is 1 unit. What do I mean 1 unit? That means the measure is 1 and the unit can be anything. It can be, say, 1 centimeter, it can be 1 meter, it can be 1 feet, so on and so forth. It does not matter for the purposes of our example. Now, we are asked what is the length AC? Can we find out length AC? So, if you recall, for a right angle triangle, hypotenuse square AC is equal to, from Pythagoras theorem we know that hypotenuse square is equal to the sum of squares of the other two sides. So AC square will be equal to AB square plus BC square. Now AB is given as 1, so it will be 1 square, plus BC is given as 1, it will be 1 square. Now what is square? So you know that so if we do A square, square simply means that number multiplied by itself, right? So 1 square will be simply 1 multiplied by 1, which in this case is 1. So we have 1 square is 1 plus 1 square is 1, or this is 2. So what we have is we have AC square equals to 2. So how are we going to find out AC? So we are going to square root both sides. So we have AC square here, left side, and we are going to square root 2. So or actually this will be plus minus square root 2. So or we will say AC is equal to plus minus square root 2. That means it can be plus square root 2 or it can be minus square root 2. Now the reason why do I have plus minus square root 2, right? That is because if you take plus square root 2 and if you do a whole square, you will get square root 2 times square root 2, which will be 2. If you take minus square root 2 whole square, that will be minus square root 2 multiplied by minus square root 2, which will be again 2. But because in our example AC is the length of it's a length, it cannot be a negative number. So in our example, AC will be equal to plus square root 2. So if you look at this number, plus square root 2, what is this? Is this a rational number? We know so far, we have seen all natural numbers, whole numbers, integers, and all rational numbers. Rational number is any number that we can write in the form of p by q, where both p, q are integers and q not equal to 0. Can we write the square root 2 in this form? The maximum we can do is we can divide this by 1, because we know that any number can be divided by 1 and stays the same number. So even if I write square root 2 as square root 2 by 1, can we say these two are equal? Can we say square root 2 by 1 is equals p by q, where both p, q are integers, q not equal 0? Well, 1 is an integer, that is alright. But what about p? Or what about square root 2? Is square root 2 an integer? Clearly square root 2 is not an integer. We know that plus 2 is an integer, we know minus 2 is an integer, but square root 2 definitely is not an integer. So what is square root 2? Let's take a look at one more example. Say it is given, so we have been given a square over here, and say it is given that area of a square, it is given area of a square, let's say 7 square units. So what do I mean by square units? Again, the unit can be anything. So if the length of the square, each side is given in centimeter, this will be 7 square centimeter or centimeter square. If the length is given in feet, it will be 7 square feet. So let's assume, so this is a square, so all of the sides are equal and these angles are 90 degrees, right? Now we know that square, so if this side is A, this will be A, this will be A, this will be A. So how are we going to find out the length A? So we know area of a square is simply A times A, or side times side, and this is given as 7 in our example. So we have A square equals 7. So how are we going to solve it? So or we are going to square root both sides. So we will have plus minus square root 7. Or because the side cannot be negative, a will be equal to plus square root 7. So again, we are seeing this number like the way we saw square root 2. So we are seeing square root 7, but that we cannot express as a rational number. So what we realize is we have these numbers square root 2, square root 3, square root 5, square root 6, square root 7, square root 8, square root 10, square root 11. There are infinite such numbers. There are infinite such numbers, and there are other numbers like pi, and we'll talk about all of that in greater detail later. There are infinite numbers that we cannot express in the form of p by q, where q is not equal to 0 and both p, q are integers. So what do we call these numbers? We have to come up with a brand new classification of numbers, and we call these numbers irrational numbers. Irrational numbers. Now, if you notice, we omitted square root 1. We did not include it. Similarly, here we omitted square root 4. We did not include it. Here we left out square root 9. We did not include it. Now, why is that? So, if you take square root 1, that is equal to plus minus 1. Why? Because if you take plus 1 and you square it, you get 1. If you take minus 1 and you square it, you get 1. So square root of plus minus 1 will be plus 1 or minus 1, and both are integers. So square root 1 is an integer. Similarly, square root 4, if you do square root 4, that will be plus minus 2. So which both are integers. Square root 9 is again plus minus 3, and both are integers. In other words, if you write down all the natural numbers 1, 2, 3, 4, 5, so on and so forth till infinity, right? And if you square these, if you square them, what do you get? For here you get 1, here you get 4, here you get 9, here you get 16, here you get 25, so on and so forth, right? So if I square 1, if I do square root of 1, I do square root of 2, I do square root of 9, square root of 16, square root of 25. These numbers will give me, in this case, plus minus 1. Here I will get plus minus 2. Here I'll get plus minus 3. Here I'll get plus minus 4. Here I'll get plus minus 5. So these numbers, that is square root 1, square root 4, square root 9, square root 16, square root 25, these numbers I cannot include in this list. Because when you square root these numbers, you do get integers. It is these other numbers, which are unusual, and we call them irrational numbers. So you can imagine we have infinitely many rational numbers. In this case, let's call natural numbers. So wherever we have the in-between numbers, and when we square root them, we don't get integers. So square root of any of those numbers will be an irrational number. So we have infinitely many irrational numbers. So how were we to define irrational numbers? Irrational meaning not rational. So what we do is we simply say that any number that we cannot express in the form p by q, where both p, q are integers, q not equals 0. If we cannot express them in this form, those numbers are called irrational numbers.